Here we're asked to use the second derivative test to find the relative extrema of the function f of x is equal to x to the third minus 3x squared plus 3. Let's see what that process looks like. We're going to start with f prime of x being equal to 3x squared minus 6x. And that's going to have zeros, definitely when x is 0. Oops. And it looks like also when potentially x is 2. Let's see. If we divide 3 out and then factor, we're going to have 0 is equal to x times x minus 2. That would give me, if I multiplied it back out, x squared minus 2x. Multiply everything by 3, 3x squared minus 6x. So we're going to have zeros when x is 0 and when x is 2. Now by the first derivative test, we'd set up a sign chart and look for places where the function changes from increasing to decreasing or from decreasing to increasing. With the second derivative test, we're going to find the second derivative. In this case, it is f double prime of x is equal to 6x minus 6. And we're going to plug these numbers in and see what values we get. So for instance, f double prime of 0 is going to be equal to 6 times 0 minus 6, or negative 6. That says when x is 0, we're concave down. That implies that we have a relative maximum at the point 0, comma, and if we plug 0 into the original function, we'll find that we get 3 for a y value. F double prime of 2, 6 times 2 minus 6, is going to be equal to a positive 6. That says we're concave up there. That implies that we must have a relative minimum. And when x is 2, let's see what we get for a function value. We are going to have 2 to the third power minus 3 times 2 squared plus 3. And I get negative 1. You can repeat you could do this problem again using the first derivative test to confirm this. You could also graph the equation in question and confirm this. But this is just a different process to go through to find relative extrema, making use of both the first and the second derivatives. One thing you do want to pay attention to, though, is the fact that the second derivative is not always conclusive. If the second derivative test is 0, then we don't know whether we have a relative extreme point or not, and you'll need to go back to the first derivative test to check it. It doesn't happen very often, though. Second derivative test is going to work the vast majority of the time. The question really becomes, how difficult is it to find the second derivative? In this case, it was pretty simple. We were able to find the relative extrema fairly quickly.